Hi, this is a second recording in support of investigation 3. I am going to do the same thing with another example. In this case, I'm in the one proportion applet and I've set the probability at 0.5, the number of tosses at 50, and done a bunch of repetitions. You can see the results. I'm going to change this to proportion of heads, and I'm making up the statistic of 0.6 that we're going to compare. And we can see that it is not particularly surprising to see 0.6 when our probability is 0.5, in this case with 50 tosses, because my p-value is 0.1, which is well over our typical cutoff of 0.05. I'm going to make this two-sided because I'm looking for a confidence interval, which is a sandwiching of the data in the middle. So instead of the red areas, I'm interested in the black area. What are the cutoffs that everything in the middle should be plausible to some degree? And so what are the cutoffs where they stop being plausible? So what I'm going to use are the sliders. And you can see the starting probability matches the probability that I set at the top. And now I'm going to move them to the left and then to the right to see where the p-value becomes 0.05, and then that will be my cutoff. In the investigation where I wrote, I said you might want to change the greater than to less than, but I don't see that that's necessary, so I wouldn't worry about that. So now I'm going to move to the left, and I'm looking for a value of 0.05. I'm getting close already. And I'm just going to do my best. There, that's close to 0.05. So I'm going to record that value. The probability here is 0.458. And now I'm going to go to the right and look for a p-value that is 0.05. That's pretty close. Oh shoot, I had a better one there. There, let's go with that. So 0.055 is pretty close. So my p-value now is 0.729. So I'm going to write that down so we don't forget what it is. So now I'm going to go to a different applet and hold on. And then there we go. So I'm going to remember these numbers 0.458 to 0.729. And I'm going to go over to the theory-based inference. And I'm going to input my sample size, which was 50, and then our proportion was 0.6. We'll calculate a count and ask it what the confidence interval should be. And so it is calculating a 95% confidence interval. And you can see that 0.4642 is somewhat close to what I had. And it's not going to be perfect because, or it's not going to be a perfect match for two reasons. Right now, I'm looking at the theory based on the normal curve. So it's a calculation with formulas. And before, I was looking at the result of a simulation, which is the tossing of the coins. And so it's going to have different results. Also, these little slider things are not very sensitive. So I had trouble locking in to 0.05. So it's not going to be a perfect match. So those are two different ways you can do that.